All right. Thank you, Tom. Please, take it away. Thank you so much.
So thank you very much for the introduction and for inviting us to give this talk today. I'll start by saying that you're going to get two talks today. I'm going to begin for around the first half hour and give a general overview of how generative AI can be used in sociological research and social sciences more broadly. And then Danny's going to spend the last 15 minutes or so talking about a collaborative project we're working on. So just as a little background about this, why are we both doing this presentation? Well, Danny and I co-organized the first workshop on sociology and generative AI this spring at Yale University, which I think was a big success. And we're currently guest editing a special issue of sociological methods and research on the topic, which is scheduled for publication in the spring. So it's a topic we're both very interested in and actively researching. So as you all know, generative AI is a topic that has really exploded in growth over the past couple of years, particularly since the release of ChatGPT in late 2022. We can see, for example, if we look at Google search trends, that interest in the topic is already eclipsing interest in other kind of data science topics, things like R, Python, and machine learning. And this has also led to lots of attention in the media. There's been fears about generative AI, the role of generative AI in people's interpersonal relationships, or even these fears that, chatbots could, somehow take over the world, leading to some experts recommending a pause on AI development that does not seem to have materialized. So there are widespread applications of generative AI across academia, from teaching, learning, literature review to research design. But my focus today is going to be squarely on methodology and how these technologies can contribute to social scientific research. So the plan for my side of the talk, I'm going to talk about 3 different applications. So this is based on a paper, and I'll share the reference at the end. It was recently published in Socius, where I discuss applications of generative AI to sociology. And I'll be talking about 3 areas today: text classification and analysis, analyzing images and multimodal media, and then synthetic media. In the paper, I also talk about qualitative research, but I'll leave that for another time. And then after this, I want to talk about some challenges, and in particular, focus on the issue of bias and its implications. So before getting further into the talk, I want to start with just some definitions. So generative AI are computational models that can generate new types of data, including text, images, and audio. Much of my talk will be focused on large language models, which are computational models of language that can generate language. And in particular, neural networks based on the transformer architecture that often have hundreds of millions or even billions of parameters and are trained on enormous amounts of text. An important part of these models that I'm sure many of you are now familiar with that really enables us to use some new capabilities is the text-to-text interface and the capacity to use natural language to interact with these models. And then multimodal models kind of extend this beyond text to think about other types of data that could be used in pre-training. So the first area I want to talk about is how these models can improve computational text analysis. And in particular, I'm going to focus on text classification. So this is a type of analysis where we're trying to automatically classify text into some predefined set of themes. So classic questions include, is a movie review positive or negative? Does a comment support or oppose a policy? Or is a tweet hate speech, which is an area that I've done a lot of research on. And there's already research showing that large language models, including some fairly early variants like BERT, which was released in 2018, can perform this task much more accurately than existing approaches. And these models can work well with relatively little training data due to the fact that they're already pre-trained on large amounts of language. And they also open up new opportunities to do what's known as in-context learning and zero-shot classification. So this is the idea that we can, for example, take a text and give it to a model and say, does this tweet, for example, contain hate speech? And it can make a prediction without necessarily ever being trained for this task. So we can generalize to new tasks. Regardless of the approach being used here, it's still critical that we have human validation. I think that there's been several papers showing that these models can perform equivalently to crowd workers, and some people, I think, are pushing for these models to even replace crowd workers, but I would argue this is very important to have humans in the loop. So I want to zoom in a little on a study I've been working on. This paper is currently under revision, where with a graduate student, Youngjun Che, we look at various different large language models and how well they can predict the stances of Facebook comments and tweets. And here this shows Facebook comments. So we look at the stance towards politicians in Facebook comments. And we find several interesting results. We find that the best performing model is ChatGPT or GPT-4o without any pre-training on this task. So if you just ask GPT-4o to classify a text, it performs better than any other model, even though it's potentially, in this case, never seen this specific data set or task. However, we also find that smaller models, including BERT variants and open source language models, can perform quite well, but only after they've been trained on larger amounts of data. And so you can see on the kind of right-hand side of this plot that some of these small models like Mistral or Llama tend to perform almost as well as the much larger models once we've given them a couple of thousand training examples. So what we were particularly interested in pushing in this paper is not just thinking about traditional kinds of classification tasks where we have a text and we have some outcome and we're predicting the relationship between them, but looking at the extent to which we can leverage the generative capabilities of these models to improve the way we do text classification. And so in this case, we wanted to look at whether we could provide models with very structured kinds of inputs that represent not just an individual text, but as a text and an entire context. So in the example you can see here, we have a post that was made on Hillary Clinton's Facebook page, along with the text of the post, and then a set of comments, or a single comment and a set of replies to the comment. So this JSON object here captures this entire short conversation in response to a post. So what we wanted to look at is whether we can use a model to jointly classify all of the replies and comments in a single pass. And so what we're trying to do here is take an input that looks like this and then generate an output that looks like this. So in this case, the model can generate a JSON object that contains the stance labels. In this case, we were interested in attitudes towards Clinton and Trump, for the reply and the comments together. And the basic idea here draws from a long-standing tradition in machine learning research known as multitask learning, where the idea is that by making multiple predictions together, we can potentially perform better than if we just split this up into separate tasks. So for example, predicting the stance of the comment helps us understand the stance of the reply, and predicting the stance of the reply's reply maybe gives us even more information. So we're kind of leveraging all of this rich information to perform classification. And what we find is that the largest language models can actually perform this task very well. So we achieve comparable accuracy to models that are just predicting a single text alone, despite this being a much more complex kind of prediction task. And we show that with relatively large open source models, so here we use the Llama 70 billion parameter model, which we were able to fine tune on our high performance compute cluster at Rutgers, we're able to actually achieve better performance than GPT-4o. So we think there's a lot of promise in leveraging the generative potential of these models to do instruction tuning for text classification. And there's a preprint of this paper on Social Archive for those of you who want to learn more. So I think there's a lot of potential to push computational text analysis forward with these models. And there are new opportunities for what Laura Nelson and Bart Bonikowski have called methodological bricolage, that we can bring together different kinds of methods in the same analysis. So for example, these language models, I showed how they can be used as classifiers, but we can also use these models to do something analogous to topic modeling, or potentially analyze the embedding spaces represented within them. And I think the conversational capacity of these models will really enable rapid prototyping, experimentation, and kind of more bespoke solutions to computational text analysis, making the methods much more flexible and accessible to kind of the discipline at large. So the next area I want to turn our attention to is the way that we can use these models for analyzing images. And so there's already work showing that advances in neural networks have opened up new possibilities for analyzing image data. So for example, we can classify images and detect pictures of collective action or protests with relatively high accuracy by fine-tuning a kind of off-the-shelf computer vision model, as Zhang and Pan show. And like LLMs, we can take these pre-trained models and then fine-tune them. We don't need to kind of make a new model from scratch. And the latest generation of these multimodal models allow us to handle both text and images in the same model. So I wanted to extend their study and look at an example here of classifying protest imagery. So this is an image taken from Wikipedia showing a Black Lives Matter protest that was actually happening in Austria in the summer of 2020. And so I wanted to see how well can this model detect that this is collective action just in a kind of zero-shot setting. So I provided a very basic prompt, described this image, and GPT-4 responded that the image shows a group of protesters and even detected that they seem to be supporting racial equality, anti-racism, and the end of police violence. So the off-the-shelf model was able to perform this task pretty well and do, previously, a couple of years ago, we had to spend some time training a model to do. But beyond simply detecting protests, these models can also extract much richer structured information from images. So I gave it the prompt to make a Python list containing the text from each sign. And we can see in the response from the model that it did a reasonably good job at extracting the text on the signs held up by the protesters and returning this in the desired format. So this is just one example that shows how we can potentially perform much more complex types of image analysis using off-the-shelf tools than were previously possible. Just a couple of years ago, we probably would have had to have trained some OCR model. We would have needed to have done segmentation to identify the signs, and it would have been a fairly complex task. But this, off-the-shelf model is able to get this information. So just like text analysis, I argue that natural language interfaces make it faster to prototype image classifiers. Prompting enables us to do these more nuanced, specific types of queries. And these types of capabilities, I think, will soon, if not already, are available for things like audio and video. So moving on from the actual analysis of these materials, I think the most innovative area opened up by large language models, and Danny will talk about how we use this for our experiment shortly, is the ability to actually create synthetic data. And so we know that synthetic images and texts can be potentially indistinguishable from the real thing. And chatbots, for example, can interact with human subjects in experimental settings in ways that kind of mirror human interactions. And I think this data presents something quite novel that's distinct from other types of data that computational social scientists have previously worked with. So Matt Solganic, in his book Bit by Bit, makes this distinction between the custom-made data that we usually have as social scientists, where we design a data set for a specific task, and this kind of repurposed, ready-made data that we're taking from other places. And I think synthetic media are potentially custom-made ready-mades in the sense that they're custom-made because we can use prompting to design an output that's very specific and fits our goals, but they're ready-made in the sense that the outputs from these models are derived from the enormous amount of found data that these models have absorbed during pre-training. So as an example of this, I wanted to see how we can use synthetic images potentially as experimental stimuli. And so in this case, I drew upon an experiment by René Flores and Ariella Schachter looking at attitudes towards immigrants. And I wanted to see whether I could generate profiles based on some of their conjoint attributes using these image models. So we can see in this case 4 images of hypothetical immigrants that are created mapping onto country of origin, gender, and occupation. And although there are some treatments that they have in their analysis that would be hard to convey with images, for example, language ability or having a criminal record, we can clearly generate these quite high fidelity images that I think could be very useful in making experiments have greater external validity. Going to the example of protests, we might, for example, generate images of protests. In this case, I varied the subject of the protest as well as the crowd size. And we might use this type of imagery in experiments where we try to understand how certain characteristics of protests affect public support. And I think critically, synthetic media allow us to generate counterfactuals. So you might think, well, we could just find images of protests and use these as stimuli, but we might not be able to create all of the kind of facets of the image that we want. And so in this case, I looked at an example of generating an image of violence, here connoted by this burning car, as a women's march protest, where we didn't find this combination of attributes in the real world, but we can see generate realistic images that convey this message. So those are the applications of these models that I think are particularly interesting. These models, of course, come with many new challenges. We know these, if you have billions of parameters, it can be extremely difficult to interpret what's going on inside the model. We often don't know very much about the training data or procedures used to create the models. The outputs are stochastic, and so in some cases may not replicate. And I think there's a growing public awareness that these models are often unreliable and they can hallucinate and they can generate misleading information. And the use of these models also raises many new ethical questions, including things like privacy. So if we share sensitive data with the model, that might get shared with a third party. There could be problematic outputs in human subject settings. And in the paper, I discuss each of these in more depth. The challenge I want to focus on here is this issue of bias, which I think has really profound methodological implications. So we know from previous research that algorithmic bias is ubiquitous in machine learning systems and potentially is more pervasive in large language models and generative AI because they've been trained on such large volumes of data from the internet. And so using these models, we need to be careful and we need to look out for biases related to particular domains. So one example that I've studied in my research, this is from a paper by colleagues at Carnegie Mellon and Washington University and some other institutions. They looked at hate speech detection models and how the same model can be biased against African Americans when African American English is used to make a statement that in standard American English would be completely innocuous. So there are potentially facets of language that are learned by the model that are then used to identify hate speech that lead to the models disproportionately predicting that in this case, tweets by African Americans are hateful. And this is something I've studied in related work. They have a nicer diagram than my paper, so I'm showing theirs here. And we know that these biases persist in large language models. So this is an example from an audit of Stable Diffusion, which is a popular image synthesis model. And the researchers here provided prompts asking the model to generate, for example, an attractive person or an emotional person. And we can see that we get very biased types of representation. So the faces that we get for an emotional person, many of them are coded feminine. If the model is asked to generate a terrorist, it generates Middle Eastern looking people. If it's asked to generate an image of a thug, it often returns images of Black people. So we see these biases within the model. So given these biases and these serious problems, are these biases, when we think of them from a social scientific perspective, is this a feature of the models or is this a bug? And I think depending what we're doing, it could be both of these. So starting with thinking about biases as, potential features, there's lots of insight to be gained from studying the biases and stereotypes embedded in these models. Potentially doing this allows us to analyze content related to social problems. And we might want to be able to generate synthetic media that have biases, for example, using them in experiments. But sometimes, these biases clearly can have negative ramifications for our studies. And the efforts that companies like OpenAI and Google are taking to mitigate biases can also potentially hamper our use of these models for social science. So earlier work has shown that we can take, for example, word embeddings, which, one of the earliest forms of neural language model, and analyze these embeddings to understand these rich social and cultural associations embedded in the models. For example, associations between gender or between poverty and different lifestyle preferences. So, for example, in this paper by Austin Kozlowski and colleagues, they look at the association between class, race, and different genres of music in word embedding models. And I think this is a very rich, kind of productive area of analysis. And if we have biased models, we can go and analyze these models and see what kinds of biases they pick up and learn something about the social world. So based on this, I wanted to see if we could use image generation models in the same way. And so drawing on their paper, I prompted DALL-E 3 to generate images that showed, in this case, I just did a very simple prompt where I said, for example, poor plus white plus music, or poor plus black plus music. And we can see that we get these very evocative scenes that have lots of connotations of both social class and race. So, for example, the ones showing white people, we have a group of people sitting in a trailer park around someone playing the guitar. We have above, we see urban scenes. And so I think there's a lot we can do in this area of probing these multimodal models to analyze their biases. Now, there have been efforts, particularly from industry, to try to mitigate biases in these models. And there's a very interesting paper that looked at early techniques for debiasing word embeddings, where they make this analogy to putting lipstick on a pig. And they say that the debiasing techniques that have been proposed for word embedding models didn't actually remove bias, they just concealed the bias. Effectively, they projected the bias into a different subspace of the model. And so I think this, to a certain extent, has been happening with some of the debiasing we've been seeing of large language models and other generative AI. So, for example, early investigations of the DALL-E models showed that these models tended to generate these stereotypical representations, where if we ask, for example, for a picture of a doctor, it would often generate a white man or an Asian man. And so what companies like OpenAI now do is if you prompt it with a prompt, like my example here, a photograph of a doctor in an office reading a medical report, the model will add demographics to your prompts to ensure that the results are sufficiently diverse, even if the underlying model is still potentially biased. And this leads to these unintended consequences, like the model that Google recently released that was widely criticized, for example, generating pictures of people of color as Nazis due to the way that they were trying to debias the prompt results. So they would add this demographic diversity that then leads to these kind of absurd images being returned. And so I think this type of mitigation creates a lot of problems for social scientists because it kind of obfuscates the bias and makes it difficult for us to analyze. And models can also just completely refuse to respond to our queries. So when I was trying to generate counterfactual images of protests with violence, ChatGPT often refused. And this is a problem I faced in my other research, in my text classification work. I've been trying to fine-tune the latest version of GPT-4o, and the API just rejects my queries and says, there's a problem with the data, it doesn't want to analyze it. So these type of refusals are an obstacle. And these even occur in these quite innocuous settings. So there's this great paper by Paul Rotger and colleagues, where they look at various different kinds of innocuous prompts that lead to what they call exaggerated safety behaviors. So I'll wrap up briefly and then hand it over to Danny. So clearly, I'm not making the case that generative AI are a panacea. They're not suitable for all research questions. And I think they don't replace, but augment existing methods and human interpretation. And I'll say that social scientists have an important role to play in studying the impact of AI on society as well. And I think Danny's part of the talk will get to that. But generative AI and large language models do provide new advances and new opportunities for computational research. I think it makes these tools more powerful, more flexible, and more accessible. And there are many applications across both computational and qualitative analysis. And with these new applications come new challenges, including practical, ethical considerations, and issues of bias. So if you'd like to learn more about this, my paper was recently published in Socius, and I'm looking forward to taking your questions at the end of this talk. So I think now I will stop sharing and I'll hand it over to Danny to go on to part 2.
Okay, can you see the slides? Yeah, excellent. Great. Well, yes, I'm Daniel Carell. I go by Danny. Thank you to the organizers and to everyone in the audience and to Tom as well for setting up the second part of the talk. So yeah, in these last few minutes, I'm going to talk briefly about a project Tom and I have been working on with a couple students of mine. We just got back the results last week, so we're excited to present this tonight and potentially get some feedback. We're calling this project Regenerating the Past, How Synthetic Summaries of Historical Events Affect Knowledge. And you'll see that it touches on a couple of the ideas that Tom brought up, for example, creating synthetic material, perhaps creating synthetic material that presents counterfactuals that we don't find in the real world, the wild, and finally studying the impacts of AI on society. Okay. So as I mentioned, this is joint work with Tom, and then Matt Chu, who's an undergraduate student here at Yale, and Kitaro Okura, who's a PhD candidate in the Department of Sociology here at Yale. Okay, so let's say that we're having a conversation about a recent event in the news, namely Boeing workers in Seattle voted to go on strike. So if you don't live in Seattle, maybe this is not a big deal, but Boeing is obviously a very large and important manufacturer in the world, and they're having a massive strike right now. So then let's say that I make a comment like, oh, well, that's not that surprising to me. Seattle, after all, Seattle has this incredible labor history, for example, the general strike. And you think, what is the Seattle general strike? So in the old days, many people might have gone to Wikipedia and read or at least skimmed an article about the Seattle general strike, which took place in 1919 and has been the only general strike in American history. Today, however, people are increasingly asking ChatGPT and other generative AI tools to describe and explain things about the world, and it might be a way to learn about this event. So the shift in behavior motivates our general research topic, which is what happens when people increasingly learn about the world and in our study, specifically history, from generative AI tools. Now, unsurprisingly, given the perhaps insufferable hype about generative AI, several researchers have explored this topic already. So some have examined how AI-generated content can shift people's opinions and beliefs, such as whether they agree with policies or political stances, or whether it changes their confidence in conspiracy theories. Other researchers have examined how generative AI, in this case manifested as chatbots, can shape interpersonal relations by mediating interaction. So imagine kind of a group of individuals and there's a chatbot involved, and having this chatbot can, for example, or this research has shown, can, for example, improve the quality of political conversations and increase performance of a group working on a task. However, we noticed that there's relatively less attention has been paid to what people know after reading synthetic content. That is, how does exposure to AI-generated content affect knowledge? So we focus specifically on how reading synthetic content can affect people's knowledge, and we kind of formulate this study around, or organize the study around, 4 research questions. First, a very basic general question here, which is that, does reading about historical events through AI-generated summaries help or hinder, or potentially have no effect, on the acquisition of knowledge relative to reading a human written summary or an organic summary. And here the existing literature sets up contrasting expectations. So synthetic content could foster knowledge because AI tools have been trained to write in clear, familiar, and comprehensible ways. However, synthetic content could also hinder knowledge because the style could be seen as derivative and uninteresting and boring, and so people pay less attention. Our second research question asks whether being informed about the AI or human provenance of a historical summary help or hinder readers' acquisition of knowledge. That is, if we tell readers that we tell people reading the summaries, whether they're reading a synthetic one or an organic one, does that matter? Some research has found that when people were told they were reading a synthetic news article, like a journalistic article, they actually expressed interest in continuing to read the article. So such interest, or in other cases, potential lack of interest, can affect the acquisition of knowledge. Our third research question is whether politically biased historical summaries promote or hinder knowledge acquisition relative to baseline AI summaries and human written summaries. So as Tom mentioned, bias is prevalent in generative AI. The models have inbuilt biases, as we just heard about. And you can imagine also users asking AI tools to create biased text. Like you actually might say, hey, tell me about the Seattle General strike, but tell it to me kind of in a conservative way, because I'm kind of politically conservative. And this might matter for knowledge because individuals encountering ideologically aligned or ideologically conflicting summaries may retain information differently. And so our final research question is whether the relationship between reading synthetic historical summaries and subsequent knowledge, whether this varies across levels of educational attainment. And this question is motivated by an obvious fact, which is that when people use generative AI tools to learn about the past, they do so already having some pre-existing knowledge of history and some experience with how best to learn, how best to obtain and retain and process new information. So therefore, we expect the pre-existing educational attainment would condition how reading synthetic summaries would affect individuals' knowledge. All right, so we examined these research questions through 2 online experiments. The first one is very basic. We recruited 193 participants, actually around 200, but we had to eliminate some participants. And we randomly assigned them to read either a human-written or organic summary of the Seattle General strike, which was written by experts at the University of Washington. Or they were randomly assigned to read a synthetic summary about the same event that was generated by GPT-4o. And then after reading the summary, participants answered 5 multiple choice questions based on facts that were in the text. And this experiment allowed us to address the first question. Essentially, does reading a synthetic or an organic summary change how much knowledge you retain? The second experiment is a little bit more complicated, as it was designed to address all 4 research questions. So here we recruited a nationally representative sample of almost 2,000 individuals, and they were randomly assigned to read 2 historical summaries, each about one different historical event: the Seattle General strike and the Third World Liberation Front protests, which, just to put briefly, led to the creation of many ethnic studies departments at US universities. So these 2 sets of summaries that each participant read, they varied in 3 ways. First, they were either organic or synthetic. If they were organic, they were condensed versions of the relevant Wikipedia page. And this is depicted here in this figure by the crowd of smiley faces, kind of like crowd knowledge here. Second, the summaries also varied by whether we labeled them as human written or generated by AI. So participants were either randomly told that this is, we're told the source of the content. And this is depicted in the image as having kind of a robber mask or being revealed, their identity being revealed. And then finally, the synthetic summaries were either a baseline type, meaning that we generated them without instructing the model to be biased, or they were biased toward being politically conservative or politically liberal. And we did this through some prompts, which I'm happy to elaborate, or some system messages and prompts, which I'm happy to elaborate in the Q&A if people are interested. And this is just, as a side note, an example of generating kind of experimental treatments or experimental conditions that we could not otherwise find in the real world. So after reading each summary, all participants answered the same fact-based questions about each event, and there were a total of 6 multiple choice questions. Okay, so let's look at the results. So first, what you see in this image, you see 2 panels, and in each panel has a results of 2 of the treatments. The green is going to be the human on the left, and then the blue color results are the AI baseline, or the responses of people who read the baseline AI synthetic summary. The red dot is the mean, and the y-axis just shows the knowledge score, how many questions they got correct. And so what you see here is our evidence answering the question, or our answer to the question of how does learning about history from synthetic summaries affect knowledge compared to learning from organic summaries. And what we found is across both studies, and we actually found the exact same treatment effect, we find that participants correctly answered more questions on average when shown the baseline or the non-politically biased synthetic summaries compared to the organic summaries. And these 2 differences are statistically significant at conventional levels. So synthetic summaries are better for knowledge. Second, does labeling the source of summaries matter? In short, no. We find that participants correctly answered more questions on average under the synthetic condition, that is the baseline AI summary, regardless of whether they were informed about the text or not, whether they were informed the text were synthetic or not. And these are the 2 box plots on the right side of this panel. So whether they knew it was AI or did not know it was AI, they still answered more questions better. So once again, just the difference between reading synthetic summaries labeled or unlabeled and reading human summaries is highly statistically significant. Third, does political bias matter? Again, the short answer is no. We find that, like the baseline AI summary, both ideologically slanted synthetic summaries led to significantly higher knowledge scores than organic summaries. So whether individuals read about these events in a conservatively framed way or liberal framed way, they still answered factual questions correctly on average more than people who read the Wikipedia page. Finally, how does a positive effect of synthetic summaries vary across levels of educational attainment? Well, we find that reading AI summaries compared to reading the human summaries helps individuals gain knowledge regardless of their educational attainment. However, the improvement caused by reading synthetic summaries is greater among individuals with a relatively less educational attainment. And we see this in this figure, which has 2 panels. On the left hand is just a bivariate model. On the right hand, we adjusted for some participant characteristics. And the gap between each coefficient plot or plot coefficient, these are predicted knowledge scores. We essentially compute the predicted knowledge scores. And we see that the gap between the human, which is green, and the AI baseline is smaller for people who had bachelor degrees or higher. And the gap is larger for individuals who had less educational attainment than bachelor's degree, meaning that there was a larger improvement among those with lower educational attainment. Okay, so there's about 15 minutes left, so I'll wrap this up. So I'll end with this quick summary and some comments on implications and areas for future research. So first, learning about history from AI tools leads to better knowledge acquisition compared to learning from human written sources. Right, that's very clear. And this effect is robust to first labeling the source, and second, political bias in the synthetic summaries. And we think this has an interesting implication. Namely, the texts generated to have an ideological valence do not necessarily convey false or misleading factual information. That is, if there's bias in the text, people still seem to learn the facts correctly. But of course, whether their opinions or their attitudes towards the facts change is a separate question. And then the third kind of conclusion is that the magnitude of the positive effect varies across educational levels, those with lower educational attainment benefiting the most. And the implication here we thought was interesting is that while AI tools can exacerbate inequalities, for example, by underrepresenting already marginalized perspectives and voices, they can also, apparently in some contexts, perhaps most benefit the most disadvantaged. So to wrap up, I'll just point out some areas of future research that Tom and I thought might be generative, of course. I have to say that pun. We saw this project as an initial initial step towards understanding how learning about the world from generative AI tools can affect people's knowledge. So there's a lot more to be done. First, future research could examine the attributes of synthetic summaries that engender the positive effect on knowledge and benefit those with lower educational attainment. So we suspect that this positive effect is due to the textual attributes of the synthetic text that make them easier to read. For example, words with fewer syllables, perhaps greater readability overall, but we have not conducted a systematic text analysis yet for this project. Second, we focus on one-off interactions. That is, somebody, prompts, you imagine somebody going to ChatGPT, asking for some information, reading the information, and then moving on with their life. However, future work could examine how knowledge acquisition changes when people have repeated interactions with AI chatbots for learning purposes, as well as what the long-term effects might be. This is important because textual attributes of synthetic style, which might be beneficial, for example, I just mentioned like greater readability, simpler words, that these might be beneficial in one-off settings, but they actually can make synthetic summaries repetitive and dull in multi-use or conversational or long-term settings, thusly hindering the positive effect if we look over a longer span of use. Finally, we find that biases in text do not necessarily hamper learning, but it's plausible that these biases could have downstream implications for people's attitudes and beliefs, as well as their interpretation of historical events. So future work could ask, what are the consequences of learning true facts from biased AI tools? All right, so that's it. Thank you. A preprint of this work, or the first write-up of this work, is available on Social Archive. And if we don't have a chance to answer any questions or address any comments, please email Tom and/or me.